Hi everyone, welcome back to Chemistry Clubhouse. Today we're going to talk about pH and pOH, or acids and bases. Gets a little bit confusing because you start dealing with these really goofy numbers. So here we go, let's get started. So let's start with 1 liter of water. All right, 1 liter of just straight distilled water. Okay, so in that 1 liter of distilled water, we have a lot of moles of water. You don't really think about it because every time we're dealing with small quantities, but if you think of this, okay, so this is 1 liter of water, which is equal to 1,000 milliliters of water. Now, because the density of water equals 1 gram per 1 milliliter, this is also equal to 1,000 grams. All right, well, now we can just do some basic dimensional analysis, and we can say, all right, for every 18 grams of distilled water, we have 1 mole of H2O. All right, and that equals 55, we'll just make it 0.6 moles of H2O. So in this beaker, we have 55.6 moles of H2O floating around. Now, the weird part about pH and pOH and acids and bases is we're dealing with the concentration of H pluses and the concentration of OH minuses. So where are they getting this? So if I have 55.6 moles of H2O, only a small fraction of those guys are breaking up. And here's how they break up. They break up into H plus OH minus. Now, very small number of those do that. Only 0.1234561 moles of these H2Os actually break up. So of those 55.6 moles of H2O, only one, we can write that in scientific notation, 1 times 10 to the negative 7th moles of H2O actually break up. Okay, so what does that mean? In this water floating around, we have 1 times 10 to the negative 7th moles of H plus, and we have 1 times 10 to the negative 7th moles of OH minus. Okay, those are just floating around. So I have these guys just randomly floating around amongst all of those tons and tons and millions upon millions of these water molecules. So obviously the majority of it is H2O floating around. All right, but amongst those, we've got that 1 times 10 to the negative 7th. Now, since this is a liter, we can actually divide that by 1 liter, and we have a concentration of 1 times 10 to the negative 7th molar H plus, and we have 1 times 10 to the negative 7th molar OH minus in distilled water. Now, you might look at that and go, why do we care? All right? Well, this is where the pH scale comes from. All right, so let's take a look. So if we have 1 times 10 to the negative 7th molar H plus, and we have 1 times 10 to the negative 7th molar OH minus, we have this little log base 10. All right, really cool. Okay, if you notice, this is to the 7th power. All right, really small number. Now what we're going to do is take the log base 10, but we're going to take the negative of it. So in other words, we're not going big numbers, we're going really small numbers. So this ends up being, if I take the negative log of this number, 1 times 10 to the negative 7th, it equals 7. All right, because what it's basically doing is just seeing to what power this number is. So down here, if I take the negative log of 1 times 10 to the negative 7th, I also get 7. Now what we call this number, we call it the pH, and we call this the pOH. All right, so these two are referencing the exact same thing. These two are referencing this exact same thing. So when I say the pH is 7, well, it's 1 times 10 to the negative 7th molar H plus. When I say the pOH is 7, it's 1 times 10 to the negative 7th molar OH minus. Now, you might know that the scale of pH, so if we look at the scale of pH, pretty goofy. We've got a 0 all the way up to 14. I wonder where that 14 comes from. Well, what's down here at 7? That is our neutral. okay? So when we have a 1 times 10 to the negative 7th molar H plus, that is our 1 times 10 to the negative 7th molar H plus, and that's neutral. Now if I go this way, all right, if I come this direction, oops, that's going to be considered acidic. And if I go this direction, that's going to be considered basic. So this is acidic, and this is basic. Now, why is it acidic and basic? Well, let's take a look. All right, let's go like right here in the middle. Let's go like 3.5. Well, what does that mean? That means it has a pH is equal to 3.5. Let's go to the other side. Let's go to them right there in the middle. All right, we go to 10.5. Well, that means it's a pH equal to 10.5. Well, what does that mean? Well, let's figure out what that concentration is. Well, we can do the opposite. All right, we can convert that number, but here's the cool part. You'd reverse that log, and now it's 10 to the negative, and then you just put that pH up there, 3.5. And we take 10 to the negative 10.5. And we just put that into our calculator. All right, so we just take 10 to the negative 3.5. Oops. And we get 0.123316. And if I take 10 to the negative 10.5, we get 3.16 times 10 to the negative 11th. All right, and that would be the molar H plus, and that would be molar H plus. Well, anything with a stronger concentration, so this number is larger than 1 times 10 to the negative 7th, and this guy is smaller than 1 times 10 to the negative 7th. So this is going to be considered acidic, and this is going to be considered basic. All right, so let's put all the pieces together. So to figure out pH, we take the negative log of the concentration of H plus. And if we're given the H plus, you just plug that in and solve for the pH. But if you're given the pH, then the concentration of H plus is equal to 10 to the negative pH. All right, now if we're given just pH, then we can use this equation, pH plus pOH equals 14. And then if we're given that pH information, then we can go to pOH, and then pOH is equal to negative log of concentration of OH minus. And then if we're given the concentration of OH minus, we get 10 to the negative pOH. All right, so these are all the equations that you're going to need to be able to use to solve these problems. So let's look at an example. All right, so let's go with 0.015 grams of KOH is dissolved in 500. Actually, let's go with 1,500 milliliters. What is the pH of the solution? All right, so first off, we need to figure out what KOH is and how many moles we have, because we need to have a concentration. So we first turn that 0.015 grams of KOH into moles. So we've got 56.1 grams of KOH for every 1 mole of KOH. All right, and this is going to give us 0.015 divided by 56.1, and we get 0.000267 moles of KOH. Now to figure out our concentration of KOH is going to be equal to our concentration of OH minus. And like we said before, when KOH dissociates, it breaks up into K plus OH minus. And we're looking for that quantity. And if we have this many moles of KOH, we have that same number of moles of OH minus. So we can just do 0.000267 moles of KOH, moles of OH minus per 1.5 liters. Again, we can convert that just by moving it over 3 spots. So now we have that number divided by 1.5, and we get 1.78 times 10 to the negative 4th molar OH minus. Now, if we look up here, we've got our concentration of OH minus, and we want to solve for pOH. So up here, we've got the negative log of OH minus. So we just plug that into the equation. So we have pOH is equal to negative log of 1.78 times 10 to the negative 4th. And that equals, rounding a little bit, 3.75. Now, don't get this confused and think that's your pH. That is equal to your pOH. Now, the question is asking for what's the pH of our solution. Well, we're not looking for the pOH, we're looking for the pH. So what's our last step? If I shrink this a little bit, all right, then what we have is pH plus pOH is equal to 14. So then pH is just 14 minus 3.75, which is equal to 10.25. And that would be considered our answer to this problem. I hope this helps. We're going to do a lot more problems, and you're going to get a lot more practice with this, but I'm hoping this gets us started with how to use pH and use concentrations and all that. Well, thanks for watching. I'll see you next time. Bye.